Welcome to your video for 2.1.2, which is going to be the section that we're going over on Tuesday. So this section is called "What is the relationship?" and it's all about angles formed by transversals. So your guys' objective for the day is to use your understanding of translations to determine that when a transversal, which we'll learn about that, intersects parallel lines, corresponding angles have equal measures. So a lot of big vocab right there. They will also continue to practice using angle relationships to solve for unknown angles. So we're going to continue to use what we learned yesterday in class to help us out with this section. So we're getting into a lot of vocab here. So that's probably one of the hardest parts, is just knowing what you're looking for and what they're asking you to find with all of your vocab here. So if you remember last class, we talked about corresponding angles, which is two angles that add up to 90 degrees. We talked about supplementary angles, which are two angles that add up to 180. And then we also talked about the vertex angles, which are the same angle measure. Okay, so two angles that are the same are also called vertex angles. So what we're going to do is we are actually going to do 2-13 together in this video. Then you guys are going to be responsible for 2-14, which talks about tiling. So if you think about a tile in a house, it all has the same kind of pattern. And what you're going to do is you're going to get a resource page, and basically you're just going to slide this image across your page and just see what angles match up and which angles are the same there. Then you are going to go into 2-15, which talks more about the tiling, and it actually gets into the actual definition of a transversal and corresponding angles, okay? So if this is something that you're get overwhelmed easily with vocabulary, definitely write it down and come back to it. And I'll try and put together a vocab sheet eventually to give you guys once we've gotten it all out there. So it just talks about transversals, and you guys will answer simple questions about this. When you guys are doing this lesson, this question, definitely write this down, because you are going to see images like this a lot. Then we go on to 2-16, which talks about corresponding angles formed by parallel lines. So that's going off of 2-15. And then you go on to 2-17 and 2-18, which talks about what angles are the same, which angles are different. Can you tell if angles are the same here? Did they give you enough information? That kind of stuff. So I'm actually going to have you skip F and G for this one, but you're going to go through and answer whether or not you can tell if those are true. So you're going to skip F and G for that one. And then for 2-18, you're going to go through and find X if possible. So that's kind of the final, you're on your own. These are what actual problems would look like. So that's super important. Here you have your methods and meanings, math notes. I'm actually not going to go over this today like I did in depth yesterday, because you can see the vocab words are things that we should know about in honors geometry at this point. Then 2-19 will be on your exit ticket, along with 21 and 22. So we are going to go over 2-23 and 2-20 together in this video. So before we get started with the examples, I just want to go over some things with you guys. So again, really important for you to know is that these angles right here are going to be the same because they are vertex angles. So they are angles formed by two intersecting lines. So you have an intersecting line here, intersecting line here. These two angles are equal, which means if those two angles are equal, we can also assume that these two angles are equal. All right, so just a quick refresher, that's vertex angle. Two intersecting lines, we can assume that those are the same. So if you actually zoom in here, and let's forget about that second line for a minute, this is also called vertex angles. So we know that this is equal to this, and this is equal to this. But what if we want bigger picture? We want more. So a transversal is a line that crosses two parallel lines. So you have two parallel lines right here. This line right here is your transversal. It crosses two parallel lines. So corresponding angles, let me see if I can erase those without, oh no. Give me a minute, let me redraw that picture. We'll go this way this time. So again, transversal is a line that crosses two parallel lines. So I drew my little arrows here to identify that those are parallel. And corresponding angles are angles that are the same position on the parallel line. So you see, let's talk about this angle right here. And if you want the corresponding angle, it's the angle that is in the same exact position on the other parallel line. So you would highlight that guy. So if you think about it, based on what you did up here yesterday, you know that this line and this line, this angle have to be equal. So those two angles have to be equal because of vertex angles, which means we can then assume that this guy is now equal to this guy because they're the same. If this angle right here, let's call this angle A, is equal to angle B because of corresponding angles, and B is equal to C because vertex angles. Wait, did I say right? A is equal to B because of corresponding angles, and B is equal to C because of vertex angles. Then we have to say that A is equal to C, which you guys are going to learn all about this in class today, so don't get super stressed out if you're like, well, what is she saying? But just kind of cool connections that you can make here, and this is why they set it up this way. That's why we go through vertex angles and then we jump down to transversals and corresponding angles. So if you didn't already, this would be a really good thing to write down and to have in your notes for tomorrow's class, or at least have an understanding about for tomorrow's class. So let's go into example 1. So as you can see, this is 2-13. So this is a quick review of what you guys did yesterday. So if you look at this, they just want to know what type of angles these are. So if you would like for a minute, maybe write them down in your notebook really quick and try and quiz yourself, okay? See how good you did yesterday in your lesson and see if you can do this right now, okay? So if we're looking at here and we're saying we want to see the relationship between angle A and B, those obviously form a 180 degree, which means they are supplementary. C and D, those are what we just reviewed. Those are vertex angles, which means they are the same. F and G are 90-degree angles, obviously. They have the little box there, which means they add up to 90, so they are complementary. And then this one is something we haven't talked about yet. So it's interesting, let's put it that way. So an isosceles triangle, one of the things that they're going to talk a lot about is the fact that it has a line of symmetry right here. So if you can fold something on top of itself, so we're folding this triangle in half, we know that H and K are going to be over top of each other. If H and K are over top of each other, that means that those two angles have to be the same. Or else, if you think about it, they wouldn't have reflection symmetry. If you can't fold it in half and have them be exactly equal, they don't have reflection symmetry. So since we've talked about this having reflection symmetry already, that means H and K have to be the same. So that's just taking an idea we did last chapter and referring it back to this chapter. So again, kind of cool that we can make those connections and put those two things together. Another thing I think about when I'm looking at this is like a piece of pizza. If you've ever folded your piece of pizza in half, the crusts are going to overline perfectly. Well, if you have a perfect piece of pizza, but you get what I'm saying. So it's going to overfold and line up perfectly, which means that one end of the crust and the other end of the crust have to be the same angle then. Alrighty? Alrighty, let's go into some homework problems. So here we see it again. So how can you tell which angles have the same measure? So this again is that idea of the symmetry. So we know that angle B and angle C have to have the same measure. So for part B, when it says that if you know angle B plus angle C equals 124 degrees, what's the measure of angle B? Again, pause the video really quick and see if you can figure it out. For this guy, all you have to do, since B and C split that angle, all you have to do is divide 124 by 2, and you get 62 for that one. Okay, again, we're just taking that idea that we just used and we are translating it to another example. And this is actually a question, a state released, an end of the course exam released question. There's one just like it. So you know that if this guy is 71, that this angle right here has to also be 71. So if that angle is 71, it's so easy to find x because all we have to do is, hopefully you said subtract it from 180. So we are going to take 180 and we are going to subtract it from 71, or subtract 71 from it. And you get x is equal to 109. The hardest part about geometry, and I know I did this when I was in high school too, is going back and making sure it makes sense. That is so, so, so important because on that state test, and even on my test, if I give you multiple choice, there are some answers you can automatically say nope. And then if you don't know, you at least have a better chance of going back and guessing. But if you think about this, if I gave you choices, let's say A is 71, B is 85, C is 109, and D is 120. You know that angle X is bigger than 90. Okay, it looks bigger than 90. It's an obtuse angle. So common sense, that one's gone and that one's gone. Now you're down to 2 answers already. So if you accidentally did something wrong and you got an angle that was smaller than 90, or you got an acute angle, that's a red flag. Go back and be like, double check your work. So just making sure everything makes sense here, guys. All right, and then the last question. So there's this whole part above, I didn't copy it, all this stuff. So he wants to see what happens if you rotate an angle, this first one, 180 degrees. All right, so we are rotating an angle 180 degrees. So if I'm going to take this first line and rotate it 180 degrees, it's going to be over here. Alrighty. Then if I want to rotate this guy 180, it's going to make another straight line this way. Wow, that was a really good drawing. Okay, so this goes back to our lesson yesterday. What kind of angle did those form? Hopefully we're all saying vertex angle. Which means if they're a vertex angle, and that's just based on assumption here, like I'm just looking at that picture and saying, hey, those really look like vertex angles. Also, think about back to our rotations. Okay, if we rotated an image 180 degree, did your points ever change? No, they reversed for 90 and they reversed back for 180. So it went back to its original points for 180. So did this image, this angle really change if you were rotating at 180? No, it stayed the same. Same thing like that question on your guys' partner quiz or team test. If I asked you to rotate your triangle 180 degrees, what happened with the slopes? They stayed the same. So you should be noticing these patterns as you're going along. Hey, if it's 180 degrees, everything's staying the same here. So that's a vertex angle. So that means they are the same. And then finally, he wants to rotate the angle 180 degrees through a different point. So on your paper, trace his shape and rotate the image. Describe the overall shape. Oh, this one's going to be a little bit more difficult. So for this one, if you think about it, all I did for this guy was I drew this straight line this way. So if I'm going to rotate this angle right here, 180 degrees, it's just going to come right back up here. And then if I'm going to rotate this guy, it's going to come off like this. And if you guys want to test my theory, you don't believe that I'm right, you guys can get trace paper out and redo it. But all I did was just turn it, because I used the same method I did here. If I'm rotating this 180 degrees, guess what it's going to make? A straight line. So if I'm rotating this little guy right here 180 degrees, it's going to make a straight line. And then all I did was connect that straight line with its arrow. So that, and it says describe the overall shape formed by the two angles. This forms a Z, but we know this is going to be equal to this angle, because if we extend this line out here, let me extend this line out here, and extend this line, we have this funny thing called a transversal. So when we intersect a transversal, we have a transversal, those lines or those angles are going to be the same, which is all stuff you guys are going to learn tomorrow in class too. You guys are going to mess around with an experiment with all those different angle measures. Alrighty, so that's all I have for you guys tonight. We will start section 2.1.2 as soon as you guys come into class. Start working on 2-14. I'll have all the resources ready for you guys in your bucket. And have a great night. I'll see you tomorrow.